Hello everybody, namaskar. So in the past previous lecture of the refrigerant, I have discussed the different variety of refrigerant used for the refrigeration system. Now in this lecture I will discuss the designation of refrigerant. Okay, so as you know that the some chemical which can be used as a refrigerant for the refrigeration system, that chemical name is very lengthy and formula also chemical formula also very difficult to remember. So that's why the Migle and Kettering they have introduced some nomenclature, so which can be easy to remember for the refrigerant. Okay, or we can say that the some code name of a refrigerant, and later the ASHRAE adopted that nomenclature for the refrigerant. So I will discuss the nomenclature of refrigerant for the different type by type. So first of all I will consider the saturated compound. Okay, so that saturated compound may be the hydrocarbon, that means the pure that natural refrigerant, or maybe the the synthetic refrigerant. So if we assume that a chemical formula of a refrigerant is given by this formula CmHnFpQl, so if this is the saturated compound, so this equation should be satisfied. So N plus P plus Q, that should be 2m plus 2. Okay, this equation should be satisfied for this formula. So for this type of refrigerant, that means the saturated compound, we can designate this refrigerant by this way: R, that is represent the refrigerant, M minus 1, this is the 1 digit, N plus 2, this is the second digit, and P, this is the third digit. Okay, so M is basically the number of carbon molecules, N is the number of hydrogen molecules, P is the number of fluorine molecules, and Q is the number of chlorine molecules. So the designation can be written by this way. For example, the C3H8, this is propane. So in case of propane, M is equal to 3 and the N is equal to 8. So that means R, M minus 1, that is 2, and N plus 1, that is 9, and P is equal to 0. So R290, that is the designation of propane. Similarly, if you take that the Cl2F2, so for this case M is equal to 1, so that means the M minus 1, that is 0. Then hydrogen, that means the N, that N value is equal to 0. So N plus 1, that is 1. Then the P is equal to 2, so that is 2, that means the R 0 on 2. So that 0, if it there after just after the R, so that can be, we can neglect, or we can basically we will in general case that is not considered. So that's why the R0 on 2 is basically the R12. Okay, so similarly third one, if you take the CHClF2, so for this case M is equal to 1, that means the R, then 1 minus 1, that is 0, then N plus 1, that is 2, then the P is equal to 2. So that is R0 on 2, so this is called the R22. Okay, so now if you take just opposite case, let's say the designation is given, then we want to find what is the chemical formula for that refrigerant. So let's say the designation is given as RABC. So ABC are the 3 digits. Okay, so ABC, so for this case formula, chemical formula will be the Ca plus 1, Hb minus 1, Fc, and Cl2a minus B minus C plus 5. So that means, for example, let's say one refrigerant nomenclature is R170. So for this case A is equal to 1, B is equal to 7, and C is equal to 0. So that means the C 1 plus 1, this is 2, and H 7 minus 1, this is 6, and other parameter C is equal to 0 for this case, so Cl also equal to 0. Okay, so that means the R170, that chemical formula is C2H6. So this is ethylene. So sorry, this is ethane. Okay, so R170, that is the ethane, C2H6. Similarly, the R32, so that we can write R032, so that means the A is equal to 0, B is equal to 3 and C is equal to 2. So that will be, chemical formula will become a CH2F2. Now we will consider the unsaturated compound. Okay, so for the unsaturated compound, the chemical formula, let's say the CmHnFpClQ. So for this case, the N plus P plus Q, that should be equal to 2m. So this equation should be satisfied for the unsaturated compound. So in case of unsaturated compound, the in case of designation, after the R we will use 1. Okay, so that means that for the unsaturated compound, the designation will be consist of 4 digit. Okay, 4 digits. So 1 is the compulsory digit, and then m minus 1, this is the another digit, then n plus 1, this is the another digit, and p is the another digit. Okay, so that m minus 1, n plus 1 and p, these three are very similar to the saturated compound, but to represent this unsaturated, 1 is used before that. Okay, for example, the C3H6, this is propylene. So for this case, the m is equal to 3 and n is equal to 6. So the nomenclature will be R1 and 3 minus 1, this is 2, and 6 plus 1, that is 7, and P is equal to 0. So R1270, this is the designation of C3H6. Similarly, if you consider the C2HCl3, so for this case, the m is equal to 2, so that means the 1, then 2 minus 1, this is 1, and H is 1, so that means the 1 plus 1, this is 2, and P is equal to 0. So R1120, this is the designation of this refrigerant. Similarly, another example, if you can take that the C3H2F4, so this is basically the fourth generation refrigerant or HFO group of refrigerant. So for this case, the m is equal to 3, n is equal to 2, and p is equal to 4. So the R on, then 2, that means the 3 minus 1, that is 2, and then 2 plus 1, that is 3, and p is equal to 4. So 4. So R 1, 2, 3, 4. This is the designation of this refrigerant. Okay, so similarly, if the designation is given for the unsaturated refrigerant, then formula we can find out. So for the unsaturated refrigerant, we have told that for the unsaturated refrigerant, the designation is consist of 4 digit. Okay, so after R, 1 is there. So let's say after R, 1 is there, then A, B, C. So for this case, formula will be the Ca plus 1, Hb minus 1, and Fc and Cl, that is the 2A minus B minus C plus 3. So example is that if you use the nomenclature R150, so for this case, basically A plus 1, that means that is 2. So C2 and 5, that means the 5 minus 1, that is 4. So C2H4. Okay, so C2H4, this is basically the formula of the nomenclature R1150. So this is the ethylene. Okay. Similarly, if you take that R1130, so for this case, chemical formula will be the Ca plus, so that is Ca plus 1, that means the C2H2Cl2. Similarly, if you take that R1318, so for this case, this will be as the C4, okay, and F8. Okay, so H, that is 0, so that means the C4F8, that is the chemical formula for the refrigerant R1318. So now some refrigerant may contain the bromine atom. Okay, so if the bromine atom is there, so for that case we have to use the B after the ABC. Okay, so after the ABC we can use the B and BQ. So Q is represent the number of bromine atom, which is basically the number of chlorine atom replaced by the bromine atom. So let's say for example, for the in case of saturated, so the designation will become Rm minus 1, N plus 1, P and BQ. So let's say for example CF3Br. So for this case, Br, number of Br atom, that is equal to 1. So that means the C, that is 1. So the R on 3. Okay, on 3. So that first one is 0. So hydrogen is 0 basically. So the R 0 on 3 B on. So we can say that is the R on 3 B on. Okay, so similarly, if the that nomenclature is given, then we have to find what will be the chemical formula for some refrigerant which contain bromine atom. So for this case, if the nomenclature is like this: R, A, B, C, B and Q. Let's say for example, so for this case the formula will be C A plus 1, B H B minus 1, F C and B R Q. So for example, R on 4, B 2. So here the A is equal to 1. So that means the 1 plus 1 C2, and that hydrogen, that will become 0, 1 minus 1, that will become 0, and fluorine F, that will be 4 plus because P is equal to 4, and then Q is equal to 2 here. So that means the Br2. So C2F4Br2, that is the chemical formula of this nomenclature. Okay, so then we will go for the higher hydrocarbon. Okay, so some cases that if the hydrocarbon in case of N is equal to more than 9, okay, some cases N is equal to more than 9 or 9. So for that case 9 plus 1 if you write, so that N plus 1, that will become a double digit. Okay, so for this case the conventional nomenclature rule, that is not applicable for this case. So that's why if this type of cases is there, for that case we can arbitrarily give some number, okay, for this type of refrigerant. Let's say for example, if you consider a butane, so butane is C4H10. So in case of N-butane C4H10, so for this case you will see that the N plus 1, that is 10 plus 1 11, so that will become a 2 digit. Okay, so that's why for this case we can use some arbitrary number 600. Okay, so for the N-butane the nomenclature will be the R600. Similarly, if you use the N-pentane C5H12, so 12 plus 1, that is 30, that is again the second double digit. So that's why for this case conventional rule is not applicable. So we can give the nomenclature R600 on. This is for pentane. Okay, similarly, another category, there is some isomer. Isomer means the same formula but different chemical structure. So for that case we will use or we will add some suffix A, B, C, etc., or any another suffix also we can use. So for example, isobutane. Okay, so isobutane and N-butane both have a same chemical formula but different structure. So if you designate the N-butane as a R600, so you can designate the isobutane as a R600A. Similarly, for the N-pentane we have used R600 on, so that's why the isopentane we can use R600 on A, like that. Similarly, the C2H2F4, so for this case we can use the nomenclature R on 34A. Similarly, in the previous slide we have used the nomenclature the R on 234YF. So YF is basically some arbitrary suffix to indicate there is some other isomers for that refrigerant. Okay, so now in some refrigerant there is a oxygen compound. Okay, so if oxygen compound is there, for that case we can designate the refrigerant in a 610 group. Okay, so for example, if the chemical formula is C4H10O, so for this case oxygen compound is there, so for this case we can give the nomenclature like R610. Similarly, the another refrigerant, let's say the C2H4O2, so for this case also oxygen compound is there, so for this case we can give some arbitrary nomenclature number like R6 on. Okay, R6 on is the nomenclature for this refrigerant. Similarly, some refrigerant, if the nitrogen compound is there, so that means if the nitrogen molecules is there, so for that case we can use the 630 series. Okay, like for example the methylamine, so for this that formula is C4H5N, so nitrogen molecules is there, so for this case we can use the nomenclature R630. Okay, so in case of inorganic compound, so in case of inorganic compound we will use the nomenclature by this way, that R700 plus the molecular weight of that compound. Okay, so for example, in case of ammonia, the molecular weight is 17. Okay, so R700 plus 17, so R7 on 7, this is the nomenclature for the ammonia. Similarly, in case of water, for this case molecular weight is 18. Okay, so 700 plus 18, so that nomenclature will be R7 on 8. Similarly, in case of air, so in case of air, this is the mixture of the different gases, so the molecular weight we can take approximately 29. So for this case the 700 plus 29, so R29, so R729, that is the nomenclature for the air. Similarly, in case of carbon dioxide, for this case the molecular weight is 44, C12. Okay, for carbon 12, for oxygen 16 into 2, so 32, to 12 plus 30, this is 44. So for this case we will use the nomenclature R700 plus 44, that means the R744. Okay, so surprisingly for this case you will see that the nitrous oxide, for this case also, in case of nitrogen, that is 14, so 14 into 2, that is 28, and 28 plus 16, that is again 44. So you will see that for the carbon dioxide and nitrous oxide, both has a same molecular weight, although these are not isomers, but both has a same molecular weight. So for that case, in case of carbon dioxide we will use simple R744, and for the nitrous oxide we will use the R744A. Okay, so then I am coming to the refrigerant mixture. So basically for the azeotropic mixture, which I have told that azeotropic mixture is behaved just like a pure refrigerant. Okay, so for this case the 500 series is used. So like R500, that is the mixture of R12 and R152A. Similarly R502, that is the mixture of R22 and R115. Similarly the R503, that is the mixture of R23 plus R13. Similarly the R507A, that is the mixture of R125 plus R143A. So these are all basically the azeotropic mixture. So for this case 500 series is used, and in case of geotropic mixture, that means the non-azeotropic mixture, for this case 400 series is used. For example, R404A, this is the mixture of R125, R143A plus and R134A. Similarly, the R407, RA, R407B, R410A. So these are all the geotropic mixture. Thank you.